So in this video we're going to take a look at solving a quadratic equation that's in standard form. And these are so difficult, this is something that we have to be creative with because we have an x squared and an x in the same equation. We can't combine them and we can't get x by itself without doing something special or different. So first of all, we learned the quadratic formula, which we need to know is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we know that the significance of this formula is that it can be used to solve any quadratic that is in standard form that is set equal to 0. So looking at the equation that I have on my left, that certainly is set equal to 0. It is also in standard form. I know that my a is 1, my b is negative 5, and my c is 6. So that means that I could use the quadratic formula to solve that equation for x. So in using the quadratic formula, it can get kind of messy to plug everything in all at once. So what I'm going to ask you to do is I'm going to say start the quadratic formula just by finding the part underneath your radical symbol. So all I'm doing is I'm taking what's underneath the radical symbol and I'm just going to find that first. That actually has a name. That's called my discriminant. And the discriminant can reveal a lot of information to us, which would also be helpful in finding it first. So I'm just going to plug in the negative 5 squared, because b is negative 5, minus, and then I'm going to separate 4 times 1 times 6. So I have 25 minus 24, which is equal to 1. So my discriminant is equal to 1. So that is my discriminant. In other words, if I go back to the quadratic formula, I know that it's going to be plus or minus the square root of 1, and that looks a lot cleaner. Now it's negative b, so it's going to be a negative 5, plus or minus the square root of 1 all over 2 times 1. So that cleans up to 5 plus or minus the square root of 1 all over 2. We know that the square root of 1 is just 1. It's a nice perfect square. So now all I have to do is take two scenarios, 5 plus 1 all over 2 and 5 minus 1 all over 2. Well, 5 plus 1 all over 2 is 6 over 2, which is 3, and 5 minus 1 all over 2 is 4 over 2, which is 2. So my answers are x equals 3 and x equals 2. So those are my final solutions to that equation. And I found those by using the quadratic formula. So let's try that again with a different example. 2x squared plus 4x plus 1 equals 0. Again, it's set equal to 0. I'm going to start with my discriminant, b squared minus 4ac. So in this case, it's 4 squared minus 4 times 2 times 1. So it's 16 minus 8, which is 8. So that's my discriminant. There's certainly nothing wrong with that. So now plugging it into the quadratic formula, I'm going to have negative 4 plus or minus the square root of 8 all over 2 times 2, which is negative 4 plus or minus the square root of 8 all over 4. The square root of 8, unfortunately, is not a perfect square. However, in my margin, I realize that I can break it down. 4 and 2, 2 and 2, 2 2's, 1 goes away. So I can rewrite this as negative 4 plus or minus 2 on the outside, radical 2, all over 4. Now if I look at the coefficients, the negative 4, the 2, and the 4, all of those can be divided by 2. So I'm just going to simplify this to negative 2 plus or minus radical 2 all over 2. That is my simplified exact answer. Now, this is certainly an irrational answer because it has a radical in it. So I'm going to find the approximate answers just by taking negative 2 plus radical 2, close parentheses, all over 2. So that's going to give me an answer of approximately negative 0.29. Then I'm going to try that again, but this time with a minus, and that's going to give me approximately negative 1.71. So here is my exact answer, and here are my approximate answers. And I had to find the approximate answers in this case because my solution was irrational. One more example, 3x squared plus x plus 4. Again, it's set equal to 0. Start by finding my discriminant, b squared minus 4ac. So this is 1 squared minus 4 times 3 times 4. So that's 1 squared, so that's 1 minus 48, which is negative 47. Now here's where finding the discriminant first is going to pay off. I know that that discriminant is going to go underneath a radical. So I know that I'm going to have negative 1 plus or minus the square root of negative 47 all over 2 times 3. Well, really, I should have stopped right up here. That is a negative number. I know that that negative number is going to be underneath a radical. For that reason, this negative discriminant I know will lead me to an equation, the formula, with a negative underneath a radical. As soon as I see a negative discriminant, I can say NRS. There's no real solution. And the reason why I can say NRS is because of that negative underneath the radical. So this equation has no real solution.